Hey guys, it's Mr. Bison here, and I'm going to be doing a video today on calculators and all the tips and tricks that you need to be able to help you to ace your maths A-level exam. So we're going to be looking specifically at the fx-CG50, which is the graphics calculator, and also at the Classwiz. Now I'm not going to be doing tutorials about how to do everything on these calculators because there's simply too much to do and there are better YouTube channels for this. I would definitely recommend the calculator guide on YouTube, absolutely brilliant channel. And what I'm going to be doing is just showing you how you can use them to get as many marks as possible in your A-level maths and further maths exams. So I'm going to kick off with the fx-CG50, the graphics, and then we're going to do some of the features from this one. Now this one's a lot cheaper, but it doesn't do as many things. So hopefully this video will help you decide which one you need. Okay, let's get started. Okay, so as I said, we're going to begin with the graphics calculator here, and the first part that I'd like to begin with is the graph section, which is actually menu option 5. So you can either scroll to that, or you can actually just press the number 5 and it will take you straight in there. So the first thing that I'd like to do is it wants us to sketch this particular graph, and it wants us to indicate the coordinates of any intersections with the coordinate axes, as well as the coordinates of the vertex, which just means the corner that we've got here. So if you want to type in this particular graph here, we need to know how to do this modulus sign, and sometimes people don't know this. So you're going to hit Option, and then you're going to press Numeric, which is F5 that you have here. And then actually this is sometimes called absolute value. So you press this ABS button, and then we're going to be able to type in this 2x minus 5 minus 3. So we're going to do 2, and anytime you want to use a variable here, you're going to press this x theta t button. So it's going to be 2x minus 5, and then we'll scroll across and we'll put in the minus 3 that we have here. Now all you do is you just press execute for it to actually draw the graph, or you can press draw that's at the top. So once it draws it, it looks a bit like this, but you may not have the numbers on your particular one. So if you want to get the numbers on there, you can press shift and then you can do setup. And then if you scroll all the way down here, you should get to a point where it says axes scale. If it's off, then you're going to not have any numbers, but if you press scale, it will have the numbers. Now, let's say that when you draw this graph, you can't see the whole thing and you want to see a little bit more. Well, I'm going to show you how to use this zoom feature really quickly as well. So when you press the zoom feature, I think the most useful one is to use F2, which is factor. So if you press this, what you want to do is I would recommend setting them as 2 and 2. So that what's actually going to happen is every time you zoom in, it will sort of zoom in by a factor of 2, and every time you zoom out, it will zoom out by a factor of 2, so it will half. So set these both to 2 by pressing 2 and then execute. And then anytime you now press plus or minus, it's going to zoom in or out. So if I press minus, it's going to zoom out twice as far. And if I press plus, it's going to zoom in as well. So sometimes that's quite useful to figure out where everything is. Now, a couple of other things that I thought I would mention is this F3, which says V window, or the visible window that you have. Now, when you press this, you get a few different options. This initial one I quite like because although the numbers look a bit strange, it's actually going to keep the x-axis and the y-axis in proportion to each other so that you can see the grid in the background is squares rather than rectangles. If you just do standard between minus 10 and 10 on both of the axes, you'll see actually that they're not in proportion, so that's sometimes not as useful. You can see we've got rectangles rather than squares there. They've got some options for trigonometry, which will usually take you, if I'm in degrees mode, between this kind of range that you have here, but it's not going to be super good for this one that we've got, so I'm going to stick with initial that we have. Okay, so it wants us to do a few different things here. Now, it wanted us to, first of all, do the sketch. So that means I can actually just go to my graph that I have here. I can draw on the sketch like this. But it did ask for us to have any intersections with the coordinate axes. So if you want to do this, you can press G solve, and that's going to do some graphical solving for you. So if I press F5, we've got a few different options here. So the root is obviously going to tell me where it crosses the x-axis. So it's pretty obvious it's going to be 1 and 4, but if it wasn't, you'd be able to do this. So you can then scroll between them, and we can see along the bottom that the roots are 1 and 4. So on my diagram here, I can label these roots 1 and 4. Now, the other things that you can do is you can use G-solve to find out the minimum, which is going to give us the vertex of this graph here. So you can also scroll around on the graph, and you can, let's just quickly try that. So you can scroll up and down like this, G-solve minimum. So the minimum value is 2.5 minus 3. So this coordinate is 2.5 minus 3. And it also wants us to know where it crosses the y-axis as well. So I'm going to do G-solve again, and I'm going to look for the y-intercept. Now the y-intercept is 2. Again, these were pretty obvious from the graph, but it's just nice in case you had a slightly more complex one like this. Okay, the second thing then is it wants us to solve this equation where we want it to solve the modulus of 2x minus 5 minus 3 is equal to a half x. So I've already got this one here on the graphics calculator. I'm now going to put in the half x. So I'm going to use my fraction button to type in the half, and then I'll scroll along and put in the x. Let's draw this. I'm just going to reset my visible window to the initial. If I can't see everything that's going on, I can always zoom out like this. Okay, so we want to find out where they are going to be intersecting each other. Now, you could do some algebra to figure this out, but what you're going to need to do is find out the intersection. So if we press G-solve and then intersect, it's going to tell us that one of the solutions that we have is that when x is equal to 0.8. So one of the solutions is that x is 0.8, which is corresponding to that. If you just scroll across, we get another solution is that x is equal to 5.3 recurring, which is 5 1/3 or 16 over 3. Now, it's probably worth saying that I wouldn't do this to solve the equation, but I would use it to verify what I've done just to make sure that it made sense. Which brings us on to how we can use the graph to do other kinds of verification. So in this one, it says verify that the maximum point on the curve with this equation between 0 and pi is this particular thing that we've got here. So let's just jump out of this one, and we're going to now delete these two by pressing delete and then F1. And I'm going to type in x minus 2 plus 2 sine x. So I'm going to do x minus 2 plus 2 sine x. Now we're talking about a maximum point on this curve in this particular range. So we're doing some calculus here, which means that we shouldn't be in degrees. So we're going to switch this in a second and make sure that it's in radians. Okay, let's draw the graph. Not going to look very good right now. So what I'm going to do is press shift. Then I'm going to press menu and I'm going to change it to angles and radians. So we're going to do shift, then I'm going to do menu for the setup, and I'm going to scroll all the way down until I get to angles, and I'm going to change it to radians and then just press execute. So now when I draw this, I'm going to get something that will look a little bit different and it's truer to what it should be. So we want to find the maximum point when x is between 0 and pi. So I'm going to use G-solve again, and I'm going to hit max. And this one down here, well, that's not between 0 and pi. So I'm going to scroll across. There we go. So it's only going to verify that it's this, because actually, if you look what I've got here, I've got that x is equal to 2.09439. This is from the calculator. And y is 1.82644 that we've got. And we just need to check that it's exactly the same as these ones that we've got. So I'm actually going to use both calculators at the same time here. I'm going to type in this 2 pi over 3 and see if we get the same thing. So we're going to do 2 pi over 3 SD, and we do get the same x coordinate of the 2.094. And then for the y coordinate, I'm going to have the 2 pi over 3. And I'm also going to add to it root 3, and then I'm going to minus 2. And we do get the 1.8264. Now, you obviously can't solve this question that we've got here, question 2, by doing just the calculator. But you would probably do all of the algebra, you would come up with these answers. You could then check it on the calculator and see if you're getting exactly the same answer. So it's not here to do the work for you, but it will verify your answers. So for question 3 that we've got here, we have another verify kind of question. It says verify that the parametric curve with these equations has gradient minus 1/8 when t equals 1. Okay, so let's jump back here and we're going to try and figure out how we can put in a parametric instead of a y equals. So I'm going to start off by deleting this one, and I'm going to change the type of equation now by pressing F3. And then I'm going to go and press param, which is for parametric. Okay. I'm also going to make sure that derivative is on for the next part, because you're not going to be able to find out the derivatives unless this feature is on. So I'm going to press shift, setup, and I'm going to scroll down here and make sure that derivative is on, and then just press execute. So I'm going to type in these two things that we've got here for my x and y. Now we're going to use this same button, but this is going to be for the parametric. It's going to be theta or t. So it's going to be 3t cubed minus t for the x one, and then the y one is just 1 over t, so 1 over t like this, and it says that t is real numbers. So I am going to draw this graph. If we can't see much what's going on here, let's just set the visible window to the initial and draw it, and then I'm going to zoom out a bit as well. So we're going to try and find out what the gradient is. We're going to try and show that the gradient is -1/8 when t equals 1. So I'm going to start off by showing you this trace one, which is F1. And when you press F1, it's going to give you all of these different bits of information. So it's going to give you dx dt, dy dt, but we want dy dx. So we want it when t is equal to 1. You can literally just press 1, and then it will tell you what t is going to be, and you can press execute, and you'll see here that dy by dx is -0.125. And we know that -0.125 is the same as -1/8. Okay, so the last one that we're going to have a look at here is we're going to verify by using the graph section of this one that the integral of sine squared x between 0 and pi is going to be pi over 2. So I'm going to jump back from here, just so you can scroll through all of these things and change t. Let's jump back here, let's delete these ones that we've got, and we're going to change the type back to a y equals 1. And I'm now going to actually just draw the graph of sine squared x. So I'm going to put this brackets. I'm going to do sine of x squared. You'll notice that this button was using x now rather than t because we've switched it to y equals rather than a parametric. And I'm going to draw this graph. Gives us quite a nice graph. Maybe I want to zoom in by pressing the plus button. And I want to integrate it between 0 and pi. So I'm going to do another feature from gsolve. And I'm going to scroll across here until I find the one that is about integrating. So I'm going to press this button, and I'm going to then press the first one again, because this is another bit of integrating. And you can either set the limits by scrolling across and just pressing the execute button, or you can set your lower limit, which is 0, by just typing in 0, execute, and then you can type in your upper limit using pi, which is shift and then the standard form button. So I'm going to do shift and then pi, and then I'm going to execute that. It's going to find that area that we've got there, and it says that the integral is 1.5707. So we've got 1.5707. We just need to verify that that's the same as pi over 2. So if I go here and I type in pi over 2, I do get 1.5707. So although I'm not going to ever do this to actually answer the question, let's say I did all of my algebra and I found out it was pi over 2, I can then check it on the calculator by using this graph one. There is another way of doing this, but I'm just showing you everything that is in the graph feature to begin with. Okay, so the next part of the menu I'm going to show you is how you can use the run matrix, which is the first one you have here. You can just press number 1 to get this. So just from the menu, you can either scroll to it or you can just hit number 1. So the first thing that I'm going to show you to do is actually like we just did on the graph section, but we can also verify this within the run matrix section. So we're going to verify that the answer to this is pi over 2 plus 2 pi root pi over 3. So let's actually just see how we get this typed in. You're going to start off by hitting math, which is F4. You're going to scroll along and then you're going to press the integral button. And then we're going to type this almost exactly like it looks here. So I'm going to open up some brackets and I'm going to type in sine of x. And then I'm going to put the squared afterwards. That's just how the calculator is going to receive that. And then I'm going to, let's put another bracket at the very beginning. So it's going to know what's going on. And I'm going to put the square root of x. Now the square root, rather annoyingly, is shift and then the square button. So I'm going to do the square root of x. And then at the end of that, I'm going to close that bracket off. And if you keep scrolling, you'll notice you can get to these limits. So I'm going to do it between 0 and pi. So shift pi that we have here. Now the calculator is very powerful and it should calculate this quite quickly, and it comes up with 5.2830 blah 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 blah. So we're just going to verify it. You wouldn't use this to answer it, you'd use it to check your answer. So I'm now just going to type in pi over 2. So it's going to be pi over 2 plus 2 pi root pi over 3. And we get exactly the same answer. So what you would do in the exam is you would actually integrate this in the long way, and you'd use your limits and you'd hopefully come up with this answer, but then you could check to see, using the first line of working that we've got here, that you've done it perfectly, and then you can just move on. So the next thing I'm going to show you is how you can check if you've done the gradient, if you've done some differentiation and some substitution into that correctly. So I'm going to verify for this particular curve here that the gradient when x is equal to root 2 is 6 minus 4 root 2. So you're going to go here and you're going to press, if you don't have quite the right menu options, you just press exit to jump back. So I'm going to press math. And I'm going to use the d by dx. You can do it for the second derivative too if you wanted to. So this is going to differentiate a function and it's going to substitute in x as well. So when you differentiate this function, you do x cubed minus 2x squared. And we want to substitute in the x value as the square root of 2. So I'm going to use the square root of 2 in here. And it gives us the answer straight away, 6 minus 4 root 2. So it can just verify it straight away. Okay, now we're going to have a look at doing something with sigma and the sums of series. So again, we're going to use the math feature. So if it's on this page, you press math. You're going to scroll along and you're going to press the sigma one that you have here. Now it wants it from r equals 2 to 11 of 3, 2 to the power of r. So we're going to do 3 brackets, close the 2 to the power of. Now it's not going to be the power of r because this variable button that we use here will only do x or theta or t. If it's ever coming up as theta or t and you want it to be x, it's because you're in the parametric version from the graph drawing, so you might need to go back and change that. So I'm going to use x instead of r, and I'm going to scroll along, and instead of it being an r here, it's going to be an x, and it's going to go from 2 to 11, and we come up with the answer straight away, which is just 12276. Okay, this is one that maybe you don't know. Maybe those previous ones you've already had a go with. But this time we're going to do lots and lots and lots of substitutions into these things that we've got here, where we have root 2 plus 1, root 2 minus 1, and 2 root 2. Now, if you wanted to type this in, it would take a really, really long time. So we're going to do something quite quick. We're going to store these values into the calculator, and then we're going to perform these calculations. So I'm going to start off by typing root 2 into the calculator. Root 2, and I'm going to hit execute so it gets stored as the answer. Then what you're going to do is use this arrow button that you've got here, and it's going to send that value, it's going to send the answer to a particular letter on the calculator. Now I want to send this to A, so I'm going to press alpha, which gets the red symbols, and then I'm going to press the x theta t button because of that small a that we've got there. So that's going to send it to A, and I just execute that so it does that. I'm going to do the same for B, so I'm going to do my root 2 plus 1, and I'm going to send that answer to B. So it's now stored in the calculator. Doesn't matter that it's gone to 1 plus root 2, it's the same thing. So for C, I'm going to do my root 2 minus 1, press execute to store it in, and then I'm going to send it to C. And then my last one is 2 root 2 for D, so I'm going to do 2 root T, execute it, and I'm going to send it to alpha D. Okay, so now I want to perform these calculations that we've got. I'm going to do A, B, C. So I'm going to do alpha A, alpha B, alpha C, plus alpha A, alpha B, alpha D, plus alpha A, alpha C, alpha D, plus alpha B, alpha C, alpha D. And it's going to do all of those values stored into the calculator and calculate it for us straight away. So that one here is going to be 11 root 2. Now, if you do further maths, you'll find this particularly useful for when you do roots of polynomials. So I'm now just going to multiply all of them together. So I can just do A, B, C, D. We come up with the answer 4. And then I'm going to add them all together. A plus B plus C plus D. And we get the answer 5 root 2. So this is useful if you've ever got values that you want to store. I mean, you can see in the background, there's so many different letters. Let's say you're doing mechanics and you've worked out the normal reaction. And let's say the normal reaction was some kind of long decimal like this. You can then store that as the normal reaction by doing alpha and then R. So you've already got it in your calculator. You don't need to keep writing that down. You've got it in its full version. Okay, this is probably one of the most powerful things about this calculator that the Classwiz does not have. It's the solve n function that you've got here. So we're going to solve this particular equation for x between 0 and 360. Now you will get no marks if you just use the calculator. I'm going to say this again. The calculator is just there to verify your work that you have done. So you cannot use this to answer the question, but you can use it to check your question's answer. So we're going to try and solve this equation. I'm going to go now, I'm going to just exit this so I can go back up to the main bit, and I'm going to press option, then calc, and then solve n. So option, calc for some calculations, and then I'm going to press this solve n1 at the end here. Now there's a couple of different ways you can do this. You then type in the equation. If you want to just type in the equation, it will try and give you all of the solutions. But if you want to find out if you want to put in a particular range, then we can do this extra part here. I'm going to do it without the extra part here. I'm going to just do this one to begin with, and we'll see what it does and we'll see how it changes. So I'm going to do 6, and I'm going to do my sine x squared, and then I'm going to do plus cos x. Oh, actually, I'm in radians mode, so in a second I'm going to need to change that. In fact, let's change it now. We can do it midway. So I'm going to go shift, setup, and we're going to go to degrees, And I'm going to just keep editing this. So that was plus cos x. Now the equals one, you don't use this for the equals one. You press shift and then the decimal point. You can see it in yellow there. And that's going to be equal to 5. And I'm just going to close off the bracket. So I've just typed in the equation. I'm just doing this bottom one here. Now when I press execute, it does something quite scary, and it says, if it's going to work, more solutions may exist. So I've said it may not give exact values and it may not give all of the solutions, but it's really good to check if there's any that you've got missing. So I'm going to press exit, and then it's got all of these different solutions that we've got here, and you can just scroll across and it will tell you all of the solutions to this equation. But we only want the ones between 0 and 360. So let's say I don't want that whole list that we've got there. I'm going to go back and I'm actually going to use this version. So I'm going to do the variable with a comma. So I'm going to press this comma button, and the variable that we're using in this question is x, and we want the lower limit of that variable to be 0, and we want the upper limit of that variable to be 360. So now when I press execute, it's only going to give me solutions between 0 and 360. So the answers that I've got to this one are x is equal to 60, 109.5, 250.5, and 300. Now this alone is not enough by itself, okay? You have to make sure you do the working yourself. At the end, you can use the calculator to check this. Okay, so the next thing I want to talk to you about is the equation option, which is from the menu option A. So you can either scroll to it or you can just press this one. You don't have to press alpha before you do it. So I'm going to use it to solve this simultaneous equation that I've got here. I'm going to start off by putting simultaneous, and then I'm going to press 2 because it's for two unknowns that we've got, just x and y. So you can imagine what you do. You're just going to type in the coefficients. So for the first one, I'm going to use 5, then I'm going to use -2, and then I'm going to use 5, and then I'm going to use 3, 4, and 8. 3, 4, and 8. When I press execute, it's going to give me the answers for x and y. So it tells me that x is 18 over 13, and that y, if I scroll down, is 25 over 26. And obviously you can press the SD button and it will take you back and forth between decimal and fraction. Now the second one that we've got here, it's not kind of obvious that you could use the calculator to do this, but it's definitely something that I would recommend you doing. And it's something that also you would get full marks for in the mark scheme for this. So it wants us to solve this equation, and it tells us a couple of things about t and v here. So I'm going to start off by subbing them in. So it says when v equals 30, t equals 1, and we want to find out what a and b are. So it would be a plus b e to the -2 times 1, which is just -2. And then we have when t is 4, v is 2.5. So I get 2.5 is equal to a plus b e to the -2 times 4, which is just -8. Now, this might not be obvious, but this is also just a simultaneous equation, and it's a linear simultaneous equation because this is just a number and this is just a number, and the coefficient of a is just 1 here. So for this first equation, although it says x and y, I'm going to pretend that it's a and b instead. So I'm going to press 1 for the coefficient, and then I'm going to type in e to the -2. So you can press shift and then ln to get e and -2, and that's equal to 30. For the next one, I'm going to do 1 for the coefficient, and then I'm going to do e to the -8. So it's e to the -8, and that's equal to 2.5. So remember, when it gives me x and y, it's actually going to be a and b. So this tells me that my value of a is going to be 2.43, and that's to 3 significant figures. And then it's going to tell me that my value of b is going to be 204 to 3 significant figures. And this is perfectly acceptable to do. Anytime you have simultaneous equations like this, this is exactly what the examiners would be expecting. Obviously, you probably know how to do this one already, but I'm going to just jump back, and instead of doing simultaneous, I'm going to change it to polynomial, and then I'm going to say that the degree is 2 because it's a quadratic. Obviously, you can do cubics, quartics, etc. So I'm going to press 2 for it being a quadratic, and although my one is an x squared equation, ours is an a squared, it's still going to be the same thing. So the coefficients are going to be 1, -5, and 3. And you can just press the execute button and it's going to give us the solutions. Now our solutions are going to be 5 plus root 13 over 2. And the other one is 5 minus root 13 over 2. So I'm just going to be lazy and put that minus sign in there. Now this one is a good opportunity to use the polynomial equation, even though it's trigonometry. Now you might notice after a bit of rearranging that this equation that we've got here is actually what I call a pseudo-quadratic or a quadratic in disguise. So if I make everything be equal to 0, we've got something that has got a sine squared, a sine, and a constant. So if I solve this using the polynomial, it won't tell me what x is equal to, it will tell me what sine x is equal to. So I'm going to jump back, I'm going to press 1 for the first coefficient because there's no number in front of it, then I'm going to press -4 for the next one, and then 1 for the constant. So when I solve this, it's not going to tell me what x is equal to, but it's actually saying that sine x is either going to be equal to 2 plus root 3, or sine x is going to be equal to the other solution, which is 2 minus root 3. Now, if you look here, 2 plus root 3 we can see is way too big because sine is only going to have a solution between 1 and -1. So this first one here is going to have no solutions. And then what you could do with this one is you could figure out what x is by doing the inverse sine of 2 minus root 3, etc. But it's just a quick way of figuring out what the sine x part is going to be. Okay, the last part that I wanted to talk to you is some of the features that you can do with statistics on this calculator, because they are much better than the Classwiz. So I'm going to jump back to the menu and I'm going to press number 2 for statistics, or you could scroll there and press execute. And we're going to use it to begin with to do some things to do with the binomial distribution. Now, I actually personally prefer using BCD, which is the binomial cumulative distribution, for all of these things that we've got here, even for ones that are equals to. And that's one of the features that I really like about this calculator. The Classwiz only allows you to do less than or equal to. This one, we're going to have all of these options here. So you're going to press dist for distribution, then binomial, and I'm always going to use BCD for this one. It's going to show you how I can do all of these ones. So I want the data to be on variable rather than list. And this is from when I've been doing some normal calculations, so I should probably just leave these as 0 for now. And we are going to start with what our number of trials are. So in this case, the number of trials is 30 and the probability is 0.4. Now, I'm going to use this for my lower and uppers. So it wants x to be less than or equal to 7. Well, that means the lowest thing that it could be is 0, and the biggest thing it could be is 7. So I'm just going to press execute, and I get my 0.0435. I'm going to do all of these to 2 decimal places. Now it wants me to be less than 17, so it's still going to be 0 as the lowest, but because it wants to be less than 17, it means it has to just be 1 lower, so it's going to be just between 0 and 16. And when you press execute, we get 0.9519 to 4 decimal places. Now here's one that maybe you haven't used before. It wants it to just be equal to 12. So because the lower and upper is always inclusive, I'm actually just going to put 12 as the lower, and I'm going to put 12 as the upper, and it's just going to find out the probability that it's equal to 12. No need to jump back and use BPD, the probability one, instead of the cumulative one. So when I press execute, it's actually giving me the exact probability. So 0.1474. You know what, I'm just going to quickly show you why I prefer this one. So if I jump back and I do the distribution and I do it as the PD instead, and I just change x to 12, you'll see how you get exactly the same answer, but you don't have to jump back and forth. So I'm just going to always leave it in this BCD here. Okay, so this is the one where I think it's actually better than the other calculator because you can do greater than or equal to with this one really easily. I'm just going to put the lower as 4 and the upper, because there are 30 trials, as 30. So when I press execute here, we're going to get a probability very close to 1. We get 0.9997 to 4 decimal places. And this is another great feature. You can also do it going in between values. So I'm going to put the lower as 12, and this time instead of the upper being 25, because this calculator does inclusive, I'm going to do it all the way up to 24 so that it has the correct answer. So I get a probability of 0.5689. So much more powerful than the other one, and you can do everything using binomial cumulative distribution instead. So I'm just going to show you some things that you can do with the normal distribution. Obviously this is just some tips and tricks rather than the full answer. So I'm going to go back, rather than how to do the whole thing on the calculator. So I'm going to do distribution, then I'm going to do normal, and I'm just going to do some things to do with some of the inverse functions, because I think these ones are a bit easier to use anyway. So it says, given that y is normally distributed with a mean of 120 and a standard deviation of 5, so we're going to do a mean of 120, a standard deviation of 5. We want to find out this value of a such that the probability of it being less than that is 0.2. So just looking at a quick sketch, we want it to be less than a particular value, as 0.2. So the nice feature on this one is you can switch the tail between left, right, or central. Now looking at this diagram, this tail is over on the left, so I'm going to leave it as left, and I want the area to be 0.2. So I'm going to execute that, and straight away I can find out that A is 115.8 to 1 decimal place. Now you can see what's going to happen for this next one. We want the area to be 0.35, and we want it to be on the right hand side. So I'm just going to jump back, and I'm going to switch it from the left to the right. This is something that this calculator can do, but the other one can't. And I'm going to change the area to 0.35. So I get A is equal to 121.9. Now there's this final thing that you can do here. If they ever want you to find the quartiles, the lower quartile or the upper quartile, well, that's actually talking about data that is in the the middle 50% of the data. So the lower quartile would be here, the upper quartile would be here, and the area in this middle section would be 50% or 0.5. So I'm going to switch, actually, because it's a central area, I'm going to switch it to central, and I want the area to be 0.5, and it's going to give me these two values. It's going to give me the lower quartile and the upper quartile. So that means that the lower quartile is 116.6 and the upper quartile is 123.4. So you've got these options of doing left, right, and central for this one. So I hope that these things that you've seen on this calculator might be pretty useful for you, maybe some new kinds of things. I'm just going to show you one final thing that's a bit of a nice thing. When I turn my calculator off, I press Shift and then off, you'll see it says Mr. Bison and Bison Maths. If you want to figure out how to do that, you scroll down and you go into System, and then you have, I believe on the next page, a username, which is F2. All you need to do is type it in, give yourself a password, and then when you turn your calculator off, you'll know it's yours and not someone else's. Okay, so now I'm going to take you through the fx-991EX Classwiz, and we're going to start off with the calculate section, which is just the main one that you get when you open it. So if it's not on that, press menu, and then you can either scroll, or it's just number one that says calculate. So again, this isn't going to be able to actually answer the question, but it is a way of you being able to verify that something is true. And you may recognize some of these from the previous one if you've watched that too. So you can use it to check your integration is correct. You'll see this button that you've got here. All I'm going to do is type in this expression that we've got. So I can type in, I'm going to use a bracket for this, sine of x. Now you might think, where is x? It's this button at the top. So sine of x all squared. So I'm going to put some brackets, plus the square root of x, plus the square root of x. You may need brackets around the whole thing, but I don't think you actually do. But I'm going to be safe, and I'm going to put brackets at the beginning and at the end, like this. And then I'm going to just change my limits so that I've got 0 and I've got pi. Sometimes you have to scroll around a lot. So it's pi on the top and then 0 on the bottom. And it comes up with this very, very, very long process. The other calculator, if you've seen the other part of the video, did this really quickly. This is so much weaker, this calculator. So you can see it's really struggling to come up with this answer. I'm going to see how much longer I can stall to see if it will actually give us the answer to this. You can see it's still working. Oh my goodness, if I were you, you might want to scroll through to see if it's ever going to get there. Finally, we have it. So we've got the 5.28301. Now we might want to check if it's the same as this one. So I'm actually just going to type into my calculator. I'm going to do shift, clear it first. I'm going to do shift pi over 2. What's happening here? Shift pi over 2 plus 2 pi root pi over 3. So we get 5.28. Now, if you want to go and see previous calculations, you should be able to press up and down, and then you can see that we've got exactly the right answer there for that. So we do know that this is completely true. Now we're going to do another verify. So you shouldn't use this to answer, but you can use it to check that you've got it right. We're going to find out that the gradient of this function when x is root 2 is this thing. So I'm going to press this time shift and then the integration button. So shift, better clear this. On please. So shift and then this. We're going to type in this function, again using the x button. So it's going to be x cubed minus 2x squared. And it's going to evaluate it. This line means evaluate it when x is equal to root 2. Press equals, and it comes up like this, and this calculator is not very powerful. It's going to give it as a decimal. So I'm also now going to clear this, and I'm going to do 6 minus 4 root 2. And then I can press SD, and then I can scroll up to compare it to the previous one. And yeah, they do give me exactly the same answer. So this one is also correct too. Okay, I'm going to use it to calculate this. You can notice up here above x, we've got the sigma notation. So I'm just going to clear everything that we've got. So I'm going to press shift to get the sigma notation. Now, like I said on the previous part, this is r instead of x. So we're going to have to make sure that we type x. So it's going to be 3 brackets, 2 brackets to the power of x to the power of x. And it's going between x is 2 and 11. We've changed it from r to x. And we get the answer 12,276. So this one isn't just to verify, you could literally use this to calculate it. Okay, this one, we are going to try and do lots of these calculations really quickly. So if you want to store values into this calculator, I'm going to show you how to do this. So let's just quickly clear everything that we've got. I'm going to store a equals root 2, b equals root 2 plus 1, etc. so I can do these calculations really quickly. So I'm going to start off by pressing root 2 and pressing equals, and then I'm just going to press this STO button, which is for store, and I'm going to store it. You don't have to press alpha here, and you're going to just store it in A. And you'll see that the answer that was on the calculator has now gone to A. I'm now going to do the same for the next part. I'm going to press equals just to clear this, like this, and I'm going to do root 2 plus 1, and I'm going to store this in B. Great. Now I'm going to do the root 2 minus 1. Root 2 minus 1. And I'm going to press equals, and I'm going to store it in C. And then my last one is 2 root 2. So I'm going to do 2 root 2 equals, and I'm going to store it in D. Now, if you want to check how these are, you can actually press shift and recall to see what everything looks like. So if I press shift and then store, you'll see it says recall. You'll see all the values that I've put in so far. So I've got my A, B, C, and D, just in case you've made a mistake. I'm going to clear that, and now I'm going to do these calculations. So I'm just going to do, to pull these up, I'm going to do alpha A, alpha B, alpha C, plus alpha A, alpha B, alpha D, plus alpha A, alpha C, alpha D, plus alpha B, alpha C, alpha D. And we come up with 11 root 2. So you can see how it would make your calculations quite a lot speedier if you're going to be doing lots of repeated ones. I'm going to do alpha A, alpha B, alpha C, alpha D. They're going to be all multiplied together, and we get the answer 4. And last of all, just adding them together, I'm going to do A plus B plus C plus D, and we get the answer 5 root 2. Now, if you don't want these values in your calculator anymore after you go to this recall that you've got, you can just do the reset. So if you press shift and then number 9, let's just clear this first of all, shift and then reset down here. All we want to clear this time is just the memory. So I'm going to press number 2, I'm going to press equals, and then I'm going to press the AC key. When I press shift and then recall, you'll see that everything is now a 0. Okay, only going to look at the next function of this one here. So let's go back to the menu, and this time we're going to look at equation and function, which is menu option A. So let's just go here, menu, and as we scroll through, you're going to see equation and function, and I'm going to press equals to get in here. So I did this on the previous part. I'm just going to solve these equations simultaneously. So it's a simultaneous equation, which is number 1, and I want there to be 2 unknowns. So this one actually looks really similar to what we've got here. So I can press 5 equals minus 2 equals 5, and then 3, 4, and 8. So this is just going to give me that my answer for x is 18 over 13. You're probably thinking, where is y? Hit equals again, and it will give you that answer, which is 25 over 26. And of course, you can press SD to scroll between them. Now, this one that we're going to do here doesn't look like it's actually going to be a simultaneous equation, but you can use the calculator to solve this. So it says that when t equals 1, v equals 30. So subbing that in, 30 is going to be equal to a plus b e to the minus 2. Okay, so that's actually just going to be a normal equation, but instead of x and y, we've got a and b. And when t equals 4, v equals 2.5. So I get 2.5 equals a plus b e to the minus 2 times 4, which is minus 8. So these can just be done on the simultaneous equation solver. So I'm going to go back to this page here. Instead of it being x and y, I'm going to be doing a and b. So I'm going to do the coefficient of a is 1, and the coefficient of b is e to the minus 2. So I'm going to press shift e to the minus 2, and that is equal to 30. Then I'm going to do a's coefficient is 1, b's coefficient is shift e to the minus 8, and that is equal to 2.5. Now, this is how they'd expect you to solve this. This is by far the quickest way of doing this. So it says x equals Obviously, we're talking about a here, so it's going to be 2.43 to 3 significant figures. And then when I press equals again, they say y, but we know that it's actually referring to b, and that's 204 to 3 significant figures. Okay, so we're now going to have a look at other things you can do with this. Let's go back. I'm going to go Menu, Equation and Function again. This time I just want to do a polynomial, and you'll notice this is a cubic because I've got something to the power of 3. So I'm going to do polynomial. I want it to be degree 3 this time. And I'm going to type in, even though ours is with x, I'm going to do, even though ours is with a and theirs is with x, that's not going to be a problem. So the coefficient of x cubed is going to be 1. There are no a squared terms, so I'm going to press 0. There is a minus 5 here, and then at the end we have a constant of 3. So when I press equals, we're going to come up with the answers that a is equal to minus 2.49. Press it again. A is equal to 1.83. And a is equal to 0.66, and these are to 2 decimal places. Now, obviously these aren't going to give you exact values, but it's just worth knowing it so you can check some of the answers. Again, I did do this one on the previous calculator, but I wanted to show you here. I'm going to go back to doing polynomial. So let's go Menu, Equation, Polynomial. This time it's going to be a degree 2. Now, it doesn't look like a quadratic, but if you rearrange it so you get sine squared x minus 4 sine x plus 1 equals 0, it's like a quadratic in disguise. So I'm going to do it with the coefficient of the sine just being 1. For the next part, it's going to be a minus 4, and for the end part, it's going to be a 1. When you solve this, this won't tell you what x is equal to, but it will tell you what sine x is equal to. So it's either 2 plus root 3, or sine x is equal to 2 minus root 3. Now, 2 plus root 3 is bigger than 1. So this one is going to have no solutions, and this one is going to have solutions. The next one, which is 2 minus root 3, because that is less than 1. So you could just go about that by doing the inverse sine of 2 minus root 3, etc., like that. Okay, last part we're going to do here is find the turning point of this quadratic. Now, it only works for quadratics here. We want to find the turning point of this. So I'm going to jump back to Menu. We're still on Equation and Function, and it's going to be a polynomial of degree 2 because it's a quadratic. So my coefficients are 1, minus 4, and 5. This only works with quadratics, and we want to find a turning point. Now we know a turning point is either a maximum or a minimum. So it's going to solve this one, and it's got some imaginary roots. If you do further maths, you'll know what that means. But if you keep pressing equals, it's actually going to tell you the minimum value is when x is equal to 2. So the turning point, it's now being told that it's actually going to be a minimum, and it's when x is equal to 2, y is equal to 1. So that might help you if you're ever plotting something on a graph. Okay, the very last thing about this one that we've got here is it can actually solve inequalities. This is one of the only features that this calculator has that the other one doesn't have. So I'm going to jump back, and I'm going to go to Menu, and I'm going to scroll across to the inequality section, and I'm going to go in here. It's degree 2, and I want it to be less than or equal to 0, so I'm going to press number 4 that we've got here. Now this might need rewriting, so I have it as minus y squared plus 3y plus 4 is less than or equal to 0. So my coefficients will be minus 1, 3, and 4. Now when I hit equals, it's going to give me the answers that x must be less than or equal to 1, or x must be greater than or equal to 4. So it's got these two kinds of solutions. This is the only thing this calculator can do that the other one cannot. Okay. I think this one has got tons of other features that are just regular things you can use it. You may have heard of this bit at the top, which is solve. It is not a very good feature. It won't give you all the solutions. It's not even that good for verifying stuff. If I wanted to verify an equation using this calculator, I would literally get the answer to an equation and substitute it back in. I hope if you've watched both parts of this video that you might think that this one is worth getting. Yes, it's more expensive, but there's way more things that this one can do. Okay, let's just finish up right here. So hopefully you can see that these calculators are not there to do the work for you, but they are there to be able to verify some of the things that you have done. This is such a smart thing to do when you've finished an integration question, for example. Just put it in your calculator and then see if you got the same from your manual working. If you got the same, you know you've got full marks and you can just move on to the next question. If you didn't get the same, you need to look through your answer and see, did I put a negative in the wrong place? Did I use the limits correctly? That's what I mean by how you can use your calculator smartly for an exam. The other thing I would probably say about this is just to use it as much as you can throughout the whole course, because you're going to get so much better at finding where all the buttons are and being really speedy with this. If you found this video useful, I have so many other things on my channel that I think you would also like. I've got things that teach topics in about half an hour. I've got one on trigonometry and one on differentiation, kind of summarises all of year 1 and year 2. I've got ones about everything you need to memorise for maths and for further maths, and I've also got the more detailed tutorials that go through almost like every single part of the topic, and they're actually filmed live in my classroom, so you get a bit of a different experience with that. Wishing you the best of luck with your exams, and I hope that you have a great day. Bye.